Eric, wake up! So to first begin by understanding integration by parts, you first have to do product rule, seen as integration by parts is how you undo product rule. So first, when you start with f of x times g of x and take the derivative of that, you get f prime of x times g of x plus f of x times g prime of x. Now when you take the integral of this, on the left side of the equation, the derivative just disappears, and on the right side you just write it out. Now, and you just keep on doing this, and you simplify and split the integrals just so you have an easier time plugging in variables at the end. Note how the integrals are still separated by a plus sign. Now, due to the nature of the way that integration by parts problems are written out, you move the f prime of x times g of x and the entire integral of that to the left side. Now you start by rewriting f of x and f prime of x as different variables. Due to the way that integration of parts works, we rewrite these variables as u prime of v, and v prime. And you can see this here where f of x is u, f prime of x is du, g of x is v, and g prime of x is dv. And then the formal equation of parts is u times v minus the integral of v du equals the integral of u dv, and problems are written in as the integral of u dv.
Okay, let's first start with an easy example. To start off, let's write the equation integral of u dv equals uv minus the integral of v du. First, we're going to identify both u and v. So to start the example, we're going to do integral of x e to the 2x. So in this equation, u would be x, du would be 1. To find v, we're going to have to take the antiderivative of e to the 2x, which we have to use u substitution, which in this I did not show, but it would equal 1/2 e to the 2x, and then dv would be what's given in the equation, e to the 2x. So now let's write out what the equation is shown above. So u dv, so x e to the 2x dx minus 1/2 x e to the 2x, which is uv, minus the integral of v du, which would be 1/2 e to the 2x dx. So all we do from this step is just simplify. So we would get 1/2 x e to the 2x minus 1/4 e squared 2x, and then always remember the plus c at the end of the equation.
Now that we have our answer, let's prove it and show that integration by parts and product rules are the inverses by using our integration by parts and using the product rule on that. So first, let's start by taking the derivative of our equation that we were given. What we find is when we do integration by parts, we get that 1/2 x e to the 2x minus 1/4 e to the 2x. Now start by taking the derivative, and this becomes 1/2 times x 2e to the 2x plus e 2x times 1, and this is product rule, minus 1/4 times 2e to the 2x. Now when we simplify this down, we get x e to the 2x plus 1/2 e to the 2x minus 1/2 e to the 2x, and those last two terms are the same, so they cancel out, and so we get back to that x times e to the 2x, and what we see is this does prove and check out.
So when using integration by parts, we do need to find an easy way to find u and dv, but actually there is an easy way to find that. Deciding what is u and what is dv could be done by trial and error or just by using LIAT. L, which is logs, would be your first option. Second option would be inverse trig, which is sine to the -1 or arcsine. Our third option will just be algebra. Our fourth option would be trig, and then our fifth and last option would be by exponentials.
And so we move on to example 2, the integral of x squared sine x dx. But to do this, we have to use a formula again. The integral of u dv equals u times v minus the integral of v du. But first, we have to define a few variables. U equals x squared, du equals 2x, v equals negative cosine x, and dv equals sine x. And so, the integral of x squared sine x dx is equal to negative x squared cosine x minus the integral of negative 2x cosine x dx. However, we have to do the integration by parts yet again. And so we have to rewrite the equation, the integral of negative 2x cosine x dx, where negative 2x is the algebra and cosine x is the trigonometry. Afterwards, we have to define the variables again. U equals negative 2x, du equals negative 2, v equals sine x, and dv equals cosine x. And so, the integral of negative 2x cosine x dx is equal to negative 2x sine x minus 2 cosine x. However, we have to plug it back into the original equation, where negative x squared cosine x minus the parentheses of negative 2x cosine x, minus 2 cosine x, end parentheses, plus c. And in the rewritten form, it is negative x squared cosine x plus 2x sine x plus 2 cosine x plus c. And remember the plus c.
Now we move on to example 3. So it's the integral of x cubed e to the 2x dx. Let's remember the formula. The integral of u dv equals uv minus the integral of v du. And we use y to figure out which one's going to be u and which one's going to be dv, which is done by finding out which one's done first. So we're going to write them out: u, du, v, and du. U is x cubed, dv is e to the 2x, du is 3x squared, and v is 1/2 e to the 2x. And now we move on to rewrite the integral using the formula, which is the integral of x cubed e to the 2x dx equals 1/2 x cubed e to the 2x minus the integral of 3 over 2 x e to the 2x dx. And then you see again at the end of it, the integral is still another integration by parts problem. So we go again and find u, du, v, and dv. So we go and u is 3 over 2x squared, dv is e to the 2x, so du is 3x, and v is 1/2 e to the 2x. And we move on and rewrite it again using the formula, which is the integral of 3 over 2x squared e to the 2x dx equals 3/4 x squared e to the 2x minus the integral of 3 over 2x to the e 2x dx. And then we realize it's another integration by parts problem, so we go again to find u, du, v, and dv. So in this case, u is 3 over 2x, and dv equals e to the 2x, and du is 3 over 2, and v equals 1/2 e to the 2x. Then we rewrite this part using the formula, which is the integral of 3 over 2x e to the 2x dx equals 3 over 4x to the e to the 2x minus the integral of 3/4 e to the 2x dx. And this isn't a product rule problem, so now we can take this and plug it back into the box, and we can take the whole thing that we plugged it back into and plug it back to the original. And then we're going to rewrite this thing as the whole part, which is the integral of x cubed e to the 2x dx equals 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x minus 3/4 x e to the 2x minus 3/8 e to the 2x plus c. So that part is the simplest part that we did on the bottom, that's brown, and then the bigger part is purple, which is the purple part we did. So you see how it looks in the equation. So this is just what I wrote down on the bottom, which is the integral after you apply everything that we did with the colors. Now we're going to start simplifying. So first thing we're going to do is simplify that smallest bracket in the middle inside the other side of brackets by distributing the negative, and we're going to rewrite it. Now we're going to distribute the negative again to make this thing completely simplified, which is 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus 3/4 x to the times e to the 2x minus 3/8 e to the 2x plus c. And make sure you remember c.
It is Christmas Day, and Miss Candace decides to spend the day at Disneyland instead of taking her pink car to the maintenance shop. As she slowly chew a gum, she leaves her pink house at 9 o'clock a.m. and gets stuck in insane traffic. After 2 hours, her pink car breaks down. She calls Minnie Mouse, who asks how far has she traveled from her house so she can pick her up. Fortunately, Miss Candace is highly educated in the art of calculus and knows that she can find her distance traveled using her velocity, which is modeled by v of t equals 2x times e to the x. How far has she traveled in the 2 hours?
So first let's start by writing our limits, which is the integral of 0 to 2, 2x e to the x dx. Let's start by defining our variables, u, du, v, dv. V equals e to the x dx, v equals e to the x, u equals 2x, and du equals 2. So let's start by plugging in our variables. So rewrite the integral of 0 to 2, 2x e to the x dx equals 2x e to the x minus the integral of 0 to 2, note how the limits stay the same, of 2 e to the x dx. Now when we plug in 2 for x, we get that 2 times 2 e to the 2 minus the bracket of 2 e to the 2 minus 2. And what we get is when we simplify this down, we get that she has traveled 16.778 miles. Some problems cannot be solved, such as sine e to the x. This will go into a never-ending cycle and is considered non-integrable because you don't get a solution by doing it. Thusly, these problems cannot be solved by integration of parts.